Hey, welcome guys. Yeah, so today let's prove the Taylor's theorem. Okay, so most of the people only learn about Taylor expansion, like one can write f of x summation of f derivative on k with you choose some point a and x minus n, x minus power n, and from 0 to infinity, right? So this is the most of people only learn about Taylor expansion, right? But what we are doing is that we want to prove rigorous form. So this is why you can build an arrow term, right? So before so remember that we have the mean value theorem says that f of b minus fa, if derivative exists in a ab open interval, there exists a c belongs to ab such that f of prime c b minus a, right? This is the mean value theorem. So which means that if you want to approximate f of b into f of a, right, plus a prime, you get this, right? So that means if you only write the 0-degree Taylor expansion, their difference will be controlled by the first derivative. So let me just, the 0-degree Taylor is control, the arrow term is controlled by the first derivative. Okay, so that means in general, this is true, right? So let me prove the theorem. This is the true Taylor expansion. Okay, so previous one is like the baby version. Okay, so suppose is f is defined on a real closed interval, and n is some positive integer, and f of n minus 1 is continuous, conti on ab, and f of derivative exists for any t belongs to a in a closed open interval ab. So remember that I didn't say f n's derivative is continuous, right? I only say like it exists. Okay, and the second is that for any alpha, so for any alpha beta will be distinct number. Alpha do not belongs to beta, do not the same as beta, and both of them in the AB closed interval. And one can define that's okay, so it's not that, right? So I define P of t to be fk alpha. So that means I try to approximate f, right? Write the Taylor expansion. The case Taylor is the nth, I should say the n minus 1 Taylor expansion to P of t, right? So since it exists, I think it's conti, right? So I write it as this, k minus k factorial t minus alpha k. Okay. So this is the k. So this should be n minus 1 a proxy, right? A proxy for f. Okay. So we need to prove something. We need to prove that their difference is bounded by the nth derivative. Right? Remember, this is n minus 1 derivative, n minus 1 Taylor expansion, right? So theorem. If this is true, then the previous conditions render exist x belongs to alpha beta, such that f of beta equals to p of beta plus fn of x, beta minus alpha n factorial. Okay, that means the difference of the Taylor expansion and the degree f is controlled by the nth derivative. Okay, so as what I said, the mean value theorem should be viewed as the 0-degree Taylor expansion controlled by the first derivative. Okay, so obviously, if n is 1, then it's just a MVP. Okay? But we need to prove general. Okay. So the condition is that we just prove it by using the MVP. Okay. So let's define let m to be some number such that defined to be f of beta, p of beta plus m, beta minus alpha to n. Okay, so I can define this m to be this, right? I just write it this. Okay. And I define g of t to be f of t minus p of t minus m t minus 1 t minus m t minus alpha to n. So remember, m is the degree n minus 1 polynomial. So if you go the nth derivative, then becomes 0. Okay, so easy to check that this guy is just this guy, and this is degree n polynomial, right? So it vanish, and then this guy will be n factorial. Okay, hopefully you can see this. Okay, and then this is for any t, right? Belong greater than any less than b. Okay, so in order to prove that what we claim is correct, right? What we claim is correct. What we only need is what? We only need to show we only need to show what? We only need to show what? We only need to show that there exists x belongs to alpha beta such that g of n of t, which is 0, right? If we prove this, sorry, x. If we prove this, then we just pick x into this, right? And this guy vanish, then we get m, right? So we get m equals to f of n x divided by n factorial, and we put in m, then everything is proved. Okay. Why? So, but why? Okay, so notice what? Notice that your p, let me just write down everything. So your p defined to be this, right? Yeah, so you can write down p of t more explicitly. I just write down for you guys to see if you cannot see if you don't understand it. So this is just what f of alpha a prime of alpha t minus alpha double prime alpha divided by say 2 factorial t minus alpha squared. So I just run up to the minus 1 term. Okay, so there's a observation that what? There's an observation that your p of alpha, right, is just f of alpha, right? I hope you see it because you put alpha in this guy of 0, right? And then you can easily check that the p prime of alpha, if you do a derivative and you get this term, right? And then if you do p prime plug in alpha, then all these higher terms vanish, only the linear terms survive, right? So this guy is just f of prime of alpha, right? So you can keep going, and then you can easily show, right? So you can easily show that pk alpha, k derivative is just fk alpha, right? For k equals to 0, 1 to n minus 1, okay? So which means what? Which means that this g of t, right? This g of t, the any derivative before n is 0, right? If you put alpha, right? So basically you prove that the g of alpha, g of prime alpha, up to gn minus 1 derivative alpha is 0. Okay, so let me say a reason again. Because this is n, right? So if you do not do the nth derivative and you put alpha, then this guy 0, and then I just proved that their derivative is the same if the derivative less than n, right? So basically you prove this. Okay. Right, and also from this, right? From our definition, right? From our derivation, we get g of beta is 0, right? Because g of beta is f of beta minus p beta, and minus this. So this is definition, right? So which tells me that the g of beta is 0. Okay. Right. So that we get these two, alpha and beta are 0. Right. So there exists x1 belongs to alpha and beta. This is by Rolle's theorem. So Rolle's theorem say that if you have 2 points that are the same, then there exists a point x1 belongs to it, their derivative is 0. Right. So we prove that the g of prime of x1 is 0. Right. And then your g of x1 prime, the g alpha is also the same. Right. They are both 0. So this is alpha beta. So you can use the Rolle's theorem twice, right? You get some x2 points which they are 0, right? So you get g prime of x2 is 0, where x2 belongs to alpha and x1, and you keep going. Okay, so you prove that there is this x1 such that so this is alpha and beta. So since g of, let me just write down again. So you get the g of alpha and the g of beta is 0. So there exists x1 such that g prime of x1 is 0, and the x1 belongs to alpha and beta. And you g prime of x1 is 0, so you prove that and then you also prove that the g prime of alpha is also 0, right? So you can use this to prove that there exists x2 by Rolle's theorem again, x2 such that this is alpha and x1. G prime x2 is 0, right? And you keep going. Sorry, G double prime. Okay, and you keep going, right? So you can keep going. Finally, your Gn minus alpha is 0, and you get something which is also 0, right? So finally, you prove that there exists xn, right? Such that G of n xn, which is 0 for some xn belongs to alpha and xn minus 1. Just keep doing the proof. I'll keep using the Rolle's theorem. So the key is that using Rolle's theorem n times. Okay, so that's a proof. So now you prove that some guy which is the nth derivative 0. So if the nth derivative 0, then this guy can be 0. Just pick t to be xn. Then you prove there exists this m is just the nth derivative for some point x, such that this works. So the n minus 1 times expansion arrow term is bounded by the derivative. Okay, so yeah, so this is the proof, right? Because finally, let me just make the final step clear, more clear, right? So you start from G of beta is 0, right? And so there are 0, so you get find point which is derivative 0, and you list, right? And you keep going. So the final term you will get the Gn minus 1 alpha is 0 and the Gn minus 1 some xn minus 1 0. So this is the final step that you use final Rolle's theorem again, right? So you start from here and use the final again. That you get n of xn is 0. And up to here, then you cannot use the Rolle's theorem again because there is no Gn of x alpha 0, right? So this is the final step. You go n minus 1 to n. Okay, so just using the Rolle's theorem times, then you can prove the so-called Tyler theorem. Yeah, so this is the true Tyler theorem. Okay, so let me just provide reference. You can check the Rudin and Apostle. So Rudin should be chapter 5, and you can check the Apostle for this theorem. Yeah, basically this is the Tyler theorem. And one can use Tyler theorems to do the error analysis. So let me just quickly do some example. So if some smart guy, I mean, most of the smart guy knows this sequence, right? But how do you know the error term, right? So how about m2, right? So you write m2 is exponential x minus 1 minus x squared divided by 2. And then let's say you're working on the 0b. Can you bound the m2? So by the theorem, it's very easy, right? By the theorem, we know that there is a y belongs to 0b, such that m2 of x is just the third derivative, right? So you do the 3 times, which is the same, right? So it's a third derivative by some point x, y, right, divided by 3 factorial, and b to the cube, right? So you can prove that n2 of the arrow term on this 0b section is bounded by this. And the exponential is a good, easy to approximate because this is exponential is monotone, right? So it's less than exponential b to the cube divided by 6, right? So basically you can, so now you are not just using the exponential term. You are not just doing the Tyler expansion, and you are also approximation this. Okay, another example that one can talk about is the sign, right? So if sign x, how to bound this? Suppose I care about the sign. If I choose our region, I carry 0b. Okay, so b occurring 0. Then your sign x is basically, right? You know the next, you can do your next term is that the 0, right? So you can keep going. So you know that this term is bounded by the cube term, right? So you know that this term, there exists the c belongs to 0b, such that this term is equals to f to a cube divided by f to a cube derivative x on c, and x minus 0, sorry, c minus 0 bounded by the cube divided by 3 factorial, right? Remember, this is the formula that we just used. So this if you write the second Taylor expansion, you still get x, right? So this is, you can view this is the second Taylor expansion and try to bound it, try to find error term, which is bounded by third derivative. Right? So this guy is bounded by this, right? And then the sine derivative 3 times is still minus, is a what? So you get sine, cosine, cosine, minus cosine, right? So this term, whatever this term is, this is bounded by what, right? So you get c to the cube divided by 3 factorial, and then my region is 0 for b, right? So this is bounded by b to the cube 3 factorial. Okay, so basically you prove that your sine beta minus beta is less or equal to this. Okay, so this is the error term. So basically this is the common technique to I hope I didn't do something. I hope my calculation is all correct. But this is the key point of using the so-called Taylor theorem to bound the Taylor expansion. And then you can actually compute error term, which is not just like your calculus course that some guy just say that, oh, this guy can do the infinity. Okay, and this is not correct, right? In the future I will talk about there are some function which the nth derivative always exist, but they are not the same as function f. So the Taylor expansion is not really it's powerful, but you need to know the error term. Okay, so see you guys next video. Subscribe to my channel.